Good morning. I'm going to go over some information about graphing parabolas again today. And we're going to look at what's called vertex form. That's that y equals a times x minus h squared plus k. And we'll see how it compares to our just basic parent function, y equals x squared. So again, our vertex form is y equals a times x minus h squared plus k. Now you notice I said y, but on the screen it shows f of x. Those are interchangeable names, if you will. Now remember that a makes it wider than x squared or more narrow than x squared. And as we saw the other day, when a is a negative number, it reflects across the x-axis. It's upside down. Instead of being a U shape, it's an upside down U shape. Now the vertex of our graph is at the point HK. And if you remember, we were sliding things around in our last class. But in vertex form, we can see exactly how much to slide it. We couldn't see that when it was in standard form. So we go to the right h units and up k units. So in the parentheses, if it's a negative, if it's a minus h, we go to the right that many. Outside of the parentheses, if it's a plus k, we go up. If it's a minus k, we go down. Inside the parentheses, if it's a plus, we go to the left. So it's kind of the opposite inside the parentheses of what we might think. So we're going to sketch the graph of f of x and g of x. F of x is just our plain old normal parabola. You see it there on the screen. It's got a vertex at 0, 0, and our axis of symmetry, our fold line, would be the y-axis, which is the line x equals 0. We're going to graph g of x, that is x minus 2 squared. Now our a value is 1 and our k value is 0. So if we think of it in hk terms, we have y equals 1 times x minus 2 squared plus 0. So it's the same shape. It's not more narrow or wider. It's 1. I've been moved to the right 2 and not up or down. And if you use Desmos, you can see that that's what it looks like. So here we have, it's been moved to the right 2 and not up or down. So we see that the vertex is 2, 0. The axis of symmetry is x equals 2, because our fold line would be this line right here. That's the line x equals 2. And it's not been reflected. It doesn't have any vertical stretch going on. Let's look at another one. This is similar, but we put this 2 in front of it. So we still have our parent function, f of x equals x squared, with the vertex at 0, 0, and the axis of symmetry at 0. Outside now, my a value is 2. My h value is also 2, and my k value is 0. So this is going to stretch it out, make it more narrow. This one's going to shift it to the right. I know it says minus, but you got to get your brain to think to the right. And then the plus 0 tells me we're not going to move it up or down. So you put it in Desmos, and you see it looks something like that. It's a little bit more narrow than the original x squared. It's been shifted to the right 2 places. And remember that more narrow, we call that a vertical stretch by a factor of 2. Let's look at example 3. Notice I don't have just the plain old y equals x squared function. This one is negative x squared. So my a value is a negative, which means it's going to be upside down. It's going to reflect over the x-axis. So we're going to compare negative x squared and negative x plus 2 squared. Well, this negative is still going to flip my parabola upside down. It's going to open down. This is going to shift it to the left too. Plus is the opposite of what you think. My brain thinks go to the right because plus means to the right, but not in this case. And I still have a plus 0 out here. So if I put it in the y equals a times x minus h squared plus k form, I have negative 1 for my a value. I have negative 2 for my h value, and I have 0 for my k value. Notice I wrote that as minus a negative. Remember, two minuses make a plus. Why did I do that? Because our original pattern has a times x minus h plus k. So here I can see that I'm moving to the left 2. It's still a reflection. It's still upside down because my a value is negative. So it opens down. And so now I see my vertex is at negative 2, 0, and my axis of symmetry is at x equals negative 2. Let's take a look at example 4. Almost the same, except like my example 2, I put a negative 2 in front of my parentheses. So I have my plain old x squared, but I've made it negative, so it's going to open down. It's a reflection across the x-axis. So g of x will also be a reflection across the x-axis. But this 2 means it's going to be a vertical stretch by a factor of 2. I'm still going to shift it to the left 2. And remember, inside the parentheses, that number tells us whether we go left or right. This tells us we go to the left 2. So my vertex is at negative 2, 0, and my axis of symmetry is at x equals negative 2. It's still a reflection over the x-axis, and it's a vertical stretch by a factor of 2. Notice that I didn't include the negative when I said a factor of 2. So that just tells us how much we stretch it by, not whether it's a reflection or not. So without graphing, describe the graph of each function. Now remember, we're going to compare it to our normal basic parent function. So this minus 4 is outside the squaring. That's not really a math term. That just means it's not part of what's being squared. So that means this parabola has the same shape as x squared. It's been shifted down 4. So our vertex is at the point 0, negative 4. It's not been stretched. It's not been flipped upside down. It's just been shifted down 4. Now for part B, we got a little bit more going on in part B. My a value is 1, so it's not been stretched out, but it has been shifted to the left 5 and down 2. That makes my vertex at the point negative 5, negative 2. My axis of symmetry is then x equals negative 5. On part C, we have y equals negative x minus 1 squared plus 8. So the negative means it's going to open down. That makes it a reflection across the x-axis. The minus 1 inside the parentheses means we're going to go to the right 1. And the plus 8 outside the parentheses means we're going to go up 8. So our vertex is at the point 1, 8, which means our axis of symmetry is the line x equals 1. Now it's not been stretched because it's negative 1. The negative in front of the parentheses is just negative 1. So it's the same shape, but it's been flipped upside down. It opens down. We say that's a reflection on the x-axis, and our vertex is in a different place. Let's look at this example. Describe the graph in comparison to the graph of x squared. Then graph the function. So regular x squared looks like this. I'll draw that here in black. We're going to see what g of x looks like. So it's a vertical stretch by a factor of 2. And that means it's going to be more narrow than just plain old x squared. The plus 5 means we shifted to the left 5. The plus 2 means we went up 2. So our new vertex is at the point negative 5, positive 2. So our old vertex was here at 0, 0. Negative 5, 2 means go left 5 and up 2. 1, 2, 3, 4, 5, 1, 2. So there's our new vertex. And our axis of symmetry, our fold line, is the line x equals negative 5. And it's not reflected because a is a positive number. So our graph looks something like this. How did I know? Well, I've done this enough times. But if you look at Desmos and start putting numbers in, if we make a chart over here, then when x is negative 6, y is 4. When x is negative 4, y is also 4. When x is negative 7, y is 10. When x is negative 3, y is also 10. And you can check that and see what's what. So the whole idea is that you can see what these graphs look like without having to use Desmos. You can use Desmos then as a check. So this one is going to be upside down. So it's going to open down. That is, it's a reflection over x. And inside the parentheses means we're going to go to the right 2. Now our plus number or minus number tells us how much we're going to go up or down. We're not going to go up or down. So our vertex is at the point negative or positive 2, 0, which makes our axis of symmetry the line x equals 2. Now the axis of symmetry I can use to graph this thing. So I know it's going to open upside down. So remember our x squared graph looks something like this. So the other graph is also going to be similar, but it's going to open upside down and it's going to shift. So we're going to shift it to the right 2 and we're going to open it upside down. So we can make a chart. When x is 1, 1 minus 2 is negative 1, and negative 1 squared, negative 1 times itself is positive 1, but then we make it negative. So at the point 1, negative 1, I've got a point. Now remember, this is my line of symmetry. This is my fold line. So I also have a point over here, because these two would match up. Let's see what happens when x is 0. 0 minus 2, that's negative 2. And when I square it, when I take negative 2 times negative 2, I get positive 4. But this tells me to make it negative. So 0, negative 4 And because I've got this fold line right here, the symmetry line, I've got a matching point over here. So it's not that difficult to be accurate when you make these graphs here because our parabolas are symmetric.